Good morning, and today we are talking about 12.4. We're going to be adding vectors in magnitude and direction form, okay? And here's the thing, we haven't talked about what magnitude and direction form is yet, so we'll do that in just a second. One thing I want to say before we start is so far all these lessons, for the most part, they've been pretty straightforward. Vectors have been a pretty easy topic for us. I think many of you did very well in the quiz from last week. But what we need to realize is sometimes it's a little more difficult, and today's assignment or today's lesson is one of those times. Just hang with me on the test. I'm not gonna make you do that much of this, but we do want to expose ourselves to a little bit more difficult version of the vectors. So hang with me, give it a go. So first thing I want to mention, we already know we can find our magnitude. So the magnitude of u, if it was vector u, we just take the square root of the x component, a squared, plus the b component, which is the y, and we square that. Okay, that gives us our magnitude, or the distance. Then we also can find the direction. Remember, using the inverse tan, we can find theta will equal inverse tan of b divided by a. Okay, now, if we have something in component form, a and b, this can also be written in something called magnitude and direction form. That's where the magnitude's out front, and then it's cosine theta, sine theta, whatever the direction is, that's what the theta is there. Okay, and so if we think about it, right here it says find u plus v, so vector u plus v in magnitude and direction form. And it's originally given to us in magnitude and direction form. Now, if this is the case, first thing we need to do is convert it into component form. Okay, so when we convert it into component form, for letter u, we'll start with that. We're gonna have, for the x component, it'll just be 4 times cosine of 175, and for the y, it's just 4 times sine of 175. Okay, and this will give us vector u back in component form. So kind of think of it as distributing that 4 in. Okay, so 4 cosine 175. If you're using your calculator, the TI-84 on your computer, make sure you change it into degree mode. If you're using a calculator on an app, make sure it's in degree mode. If you use Desmos.com, it's already in degrees, so you're good. But anyway, we said it was 4 times cosine of, what was it, 175? And then also 4 times sine of 175. So cosine. Now, so far we've been rounding to 2 decimal places. We want to go a little bit more. Notice here it says round every calculated value to 4 decimal places until the very last step. We got to do that because on Delta Math, otherwise if you round more, your answers will start to get off. We want to go to 4 decimal places. Okay, so if we do this, 4 cosine 175, we look and we found it was negative 3.98477. So if we round up 48, so it will equal negative 3.9848, and our y value was 0.3486. Okay, see right here, 3846. Now, that was just for our u vector. We also need to do that for v. So we'll do the same thing. I'll do this one in red. Instead of 4 at the front, our magnitude here is 5. So 5 cosine 65. And then 5 sine 65. So we type that in, 5 times cosine of 65, 5 times sine of 65. You don't have to put those parentheses. It works either way. So 2.11309, so we round up to 3.1, and 4.5315. All right. Now, we have our 2 parts in component form, our 2 vectors in component form. Step 2, we need to add those together. So I could write this out but since they're kind of complex, or they're just decimals, okay, they're not hard, but I'm just going to use a calculator. So I'll add the x components first. So 3.9848, negative 3.9848, plus 2.1131. So negative 3.9848 plus 2.1131. All right, and one thing I want to point out, if you're using this calculator, if you do this and you start with this button, hit negative, do you see how it says answer minus? We have to use this sign for a negative. So negative 3.9848 plus 2.1131. Oops, I made a mistake there. So negative 3.9848 plus 2.1131. We hit enter and we get the same thing. So our value for the x component would be negative 1.8717. Then for the y component, once again, we'll do the same thing. So let's see, what was it? It was 0.3486 plus 4.5315. Add those, we get 4.8801. Okay, now at this point, we want to identify where is this at? So which quadrant? So if we think about it, the negative x value means left, the positive y means up, somewhere up here. Hopefully you remember that is quadrant 2. We won't need that quite yet, but we will need that in a minute. So here's the vectors combined in component form, but notice in the original question it asked, our goal was to add two vectors in magnitude and direction form. Okay, and then right here, it says find them in magnitude and direction form. So we converted this to component form, found it combined in component form. Now we need to convert it back. So to do this, remember our magnitude still applies. So for u plus v, it'll be the same. We'll just obviously use when we combine them together here from step 2. So it's just the square root of negative 1.8717 squared plus here it's 4.8801 squared. Okay, this will tell us our magnitude. And obviously you can't do that in your head. Just go here, type it in, or use the calculator, the TI-84 if you prefer, whatever you prefer. Don't forget, we're going to square each component, okay, plus, we'll do the same thing, 4.8801, and we'll square that. Get 5.2267. Now, we've been going 4 decimals. On Delta Math, it actually lets you just round this final component to the 10th. So we're going to do that as well. So 5.2. Now, that's our magnitude. We need to also find the direction. So remember, for this one, theta will equal the inverse tan of, it's always the y component over the x. So 4.8801 divided by negative 1.8717. And we will find what theta is. Okay, so right here we go to function inverse tan, and then it was 4.8801 divided by negative 1.8717. And I think you guys remember that, or I hope you guys remember, if you're doing it on here, remember when you're putting a negative inside of the inverse tan, you have to use this negative button or it'll count it wrong. It'll say error. Okay, so when I did that, I got negative 69. We'll round to the nearest whole number, so negative 69. Now keep in mind, this was in quadrant 2. So that's not our final answer. Quadrant 2, if you go up here, remember to our chart from 2 lessons ago, quadrant 1 we just use as is. Quadrant 2 we have to add 180. Quadrant 3 add 180. Quadrant 4 add 360. So if I add 180 to that negative 69, I'll get 111 degrees. So now, over here is 5.2, here's 111. to write our final answer, just 5.2 cosine 111 sine 111. And that is our final answer. Okay. So obviously it took a little bit of time. I mean, these problems are a little bit more advanced, but basically 3 different steps. Convert it to component form, add it, and then convert it back. So we're going to do one more of these together today. So number 2 here, we'll start, convert it to component form. So for u over here, it'll be 2 times, let's see, oops, what am I doing? I was rewriting it. So x component is 2 cosine of 280. The y component is 2 sine of 280. Okay, then we're also going to do, I'll do it in red for v. It's going to be 7 times cosine of 25. And then 7 times sine of 25. All right. So 2 cosine of, what was it, 280. And 2 sine of 280. And then we also had 7 cosine of 25, 7 sine of 25. And you can see here those different values, okay? I could say them each, but we're going to round to 4 decimal places here. 6.34415, we round up to 42 at the end there. But that's just one example of that. So if I write these out, you could do that on your own. I don't think that's what's going to be difficult. Some of you might not want to go to 4 decimals, but it's not hard. It's just taking the time to figure it out. So there is for u, and for v, we already found this, but 6.3442 and 2.9583. Okay, step 1 is complete. Now step 2, over here in black, if we combine these, just add them up. And once again, for this, just add the x's, so 0.3473 plus 6.3442. We get 6.6915, and then you'll do the same thing, so negative 1.9696 plus 2.9583, and we get 0.9887. Okay, so that's our combined component form. And now all we have to do is convert this back into magnitude and direction form. Oops, a little typo, or I guess since I'm writing, or righto, I don't know what you call it. But there we go in black. Now all we got to do is convert that back. Okay, we got that when we added these together. So first thing we're going to do, let's decide which quadrant it's in. So if both of those are positive, it's going to be somewhere up here. Now notice that it had a positive and a negative. That was quadrant 2, or no, quadrant 3. No, what am I saying? Quadrant 4 and a quadrant 1. It combined though stays up in quadrant 1 here. Okay, so Q1. So that means whatever answer we get, that will actually be our answer for the theta. Okay. So u plus v, to find the magnitude, we take the square root of these two squared. And then over here, we'll do the inverse tan of y divided by x. And once I find both of these, I will have my final answer. Or I guess the 2 parts to make my final answer. So square roots in here, we're going to have 6.6915 raised to the second, plus, we'll do it again, 0.9887 raised to the second, We do that, we get 6.76. Remember, we just have to go to one decimal, so 6.8. That's what that equals. And we got to find what theta is. So we take the inverse tan, or tan to the -1, of, we want to do 0.9887, the y component, divided by the x component. And as you can see, 8.4, but we can round in nearest whole number, so 8 degrees. Pretty small, but that hopefully makes sense because the x is much bigger than the y. So it's over to the right and hardly up at all. So that's going to be very close to 0, so 8 degrees. So all we have to do to write our final answer, put it into magnitude and direction form. So 6.8 cosine of 8, sine of 8, close it, and that is our final answer. So before I let you go, we'll do the back tomorrow for part 2. But before I let you go, take a look on Delta Math today. It's going to walk you through these. They're a little tough, so it's going to walk you through step by step. There's some checkpoints along the way. Okay. Now notice here, it says, given the vector u with a magnitude 7 and direction 165. Now, it asks us to graph that. We have to click and drag from the origin. So we're going to start here. And some of you might be saying, I have no clue where magnitude 7 direction 165 is. But notice, as I pull it out from the origin, you see the magnitude is increasing there. The angle shows. So just put it to 7, so right there. And then at 165 is what I want. So I drag it over to 165. And right here, say I'm at 163. If I let go, that's close enough. It gives you 1 or 2 degrees. So you don't have to be perfect. It puts it there. Now I'm going to plot V. That's magnitude of 4, direction 255. So we know that's somewhere down here. Let's see. It's kind of hard to see because it's blocking it. Somewhere around there. Okay. Now all I have to do is just drag one of the vectors so you can show adding it. So I move it over here. And now I have to drag from the origin to that point. Okay. At this point, it says now answer the math questions below the graph. Okay, now is where we type in u and v. That's what we found on step 1. We'll try it. It'll tell us if we did it right. So that way there's checkpoints along the way as you go. So please give this a go. If you need any help, please let me know. This is a little longer, and I know it's a little more difficult, but I think you got it. Hang in there. We're almost done. Hope you guys have a great day.